Okay, we're gonna do the example double replacement reaction, the first one, and then you can try to do the second one, and I'll have that posted at the end of the video. So this one's gonna be a little bit longer because we also have to learn how to do the state symbols, and that depends on solubility. But we're gonna tackle the reactions first, and then we'll go back and do the solubility chart. So the way you recognize a double replacement reaction is we have two compounds before the arrow, two compounds as our reactants. They're ionic, and what we're gonna do is we'll switch them. So the positive ion ends up with the negative from the other compound. For these, I recommend using the periodic table that has the charges and the polyatomic ion reference. We have nitrate in both of these, and we're going to need to cross the charges, so that's helpful to have. With these, we are going to have the same charge on the reactant and the product side. It does not change. But the numbers at the bottom, the subscripts, will change. The only ones that are going to carry over are ones that come from polyatomic ions. So this 3 in nitrate will come over because that's part of NO3, but any other numbers at the bottom do not come over. We start fresh on the right side. So we can pair these off. The positive's always first, and the negative's always second. So this positive pairs up with a negative from the other one. That's the outsides. And we can also pair out the insides, So we have brackets there. So first we can just line them up next to each other. So PB is going to go with I. I always start with the outsides first because they're in the right order. With the middles, we have to flip-flop them because reading left to right, NO3 comes before K, but in the ionic compound, we have to write the positive one first. So K is going to come first, and then NO3. Now, so far, I've just matched up the ions. We do have to look at their charges. So as I said, the charges stay the same as we move across. The thing that's going to change is the numbers at the bottom. So we can look at our periodic table. So PB is going to switch. We'll come back to that one in a second. The other two elements we have are K and I. K is always +1. I is always -1. I'll write them up here too. Okay, to figure out what PB should be, because it could be +2 or +4, we should look at the polyatomic ion, the nitrate. If you look, it says minus, which is -1 on our reference sheet. So because there's a 2 after the NO3, that's -2 overall, so PB must be +2 in this compound. Those charges carry over, so +2, -1. So remembering that our ionic compounds should always add up to 0. The second one does. K is +1, NO3 is -1. We don't need any more subscripts. With our first compound, they do not add up to 0. So that means we should crisscross the numbers down. So the 2 from PB goes down to I. So that will be PBI2. And that would be the formulas. So noting again that there was a 2 after nitrate on the left, that does not come over. Only the 3 comes over because that's part of the polyatomic. They're all bound together. They travel as one piece. We recross the numbers on the right side. Now that we've done that, we can balance. So always write the formulas correctly, then go back and balance it. So this one, our I's are not matching and our NO3s are not matching. We can put 2's in front of KNO3 and KI, and that balances our NO3s and our I's, and we also have 2 K's. And this would be a balanced reaction. Okay, as I said, we're going to do the state symbols, but we'll do that after we go through both of these reactions. So try this second one on your own, and I'll put that up in a second. So for this one, again, pairing up the outsides and the insides, calcium ends up with NO3, and iron ends up with chlorine. Calcium is +2, nitrate is still -1. In this one, iron is +3 because of that 3 here. Chlorine is -1. So that means we need a 2 here and a 3 there. And to balance the reaction, we have 2 chlorines, but 3 here. The lowest common multiple of those is 6. To get 6 here, you put a 2, put a 3 in front of CaCl2. Same thing with the nitrates. We can put a 3 here, and that also balances the carbons. And we can put a 2 in front of this one, and then it's balanced. So that's double replacement. Pair up the inside and outside ions, bring over the ions with their charges, crisscross, and then go balance. Okay, let's look at the state symbols. So with these reactions, they are usually taking place in aqueous solution. So we take the ionic compounds and we dissolve them in water. And usually we start with 2 that can dissolve, that are soluble, so they're aqueous. And oftentimes we have a solid form on the product side. It's called a precipitate. So it would get cloudy if you were watching the reaction, or there'd be like a solid sinking to the bottom. If we mix them and they all stay aqueous, technically there's no reaction that happens. So normally I give the solubility rules for this, but this year I did a chart because it should be easier for you to read since not everyone is coming to class. So in our notes, I have the solubility chart. So we're gonna switch over. So here's the notes page. Down on the second page is the solubility table. So you find the positive ion from the column on the left, and you move over to the right for the name of the anion, the negative ion. So our first reaction, our 2 reactants, the stuff on the left side, were lead-2, which is right here, and that was paired up with nitrate, which is right here, and then we see an AQ in that box. So that means it's soluble, it dissolves in water. That's why there was an AQ for that box. We also had potassium chloride, no, iodide, potassium iodide, and we can see everything from potassium is an aqueous solution. So that one was AQ as well. On the product side, we would check our chart. We had lead-2 iodide. So if we go over to iodide, we see S. So that's a solid. This would be our precipitate. This one would get cloudy. And lead-2 iodide is actually a bright yellow compound. It used to be used in paint. And our other product, potassium nitrate, would be aqueous. So we can, I'll have to switch back again. We can fill in here. This one we said was a solid, that's our precipitate, and this one is AQ. For our second reaction, we already have the left side, so we don't need to check those. We're going to be checking for calcium nitrate and iron 3 chloride. So potassium nitrate. As I said before, potassium, they are, no, I'm looking at the wrong one. Calcium, calcium nitrate. Calcium and nitrate is AQ, so that one will be aqueous. And then we have iron 3 chloride, which is also aqueous. So both of our products for our second reaction are actually aqueous. So technically nothing reacted here. This would be just pouring 2 liquids together and nothing happens. So technically we shouldn't even write an equation for this, but we already did. So we're gonna leave it up. Okay, so that's our reactions. So you do all the balancing first and then go back and do the solubility rules. So I don't think the quiz has anything on, no, the practice might not have anything on the solubility rules, but the quiz does have one question using the state symbols. All right, that's it for that.